Well, good morning. Welcome to Doc Onco's Physics. My name is Keith Onco, and today what we want to do is looking at another one of Newton's laws problems, and this one has to do with something known as an Atwood machine. And all an Atwood machine really is it has a pulley, a frictionless pulley. It's got a single rope that's wrapped around the pulley, all right, and it's got two masses, right? It's got generally a lighter mass and one has a greater mass, okay? And what we want to do is we want to figure some stuff out about our system, okay? And again, we're going to be using Newton's second law here. The sum of the forces is equal to ma, right? And what we're trying to do here is we're trying to determine the mass of block M2. So according to the problem, it says the mass of block M1 is 6 kilograms, okay? And the pulley is frictionless, and M2 accelerates upwards, okay? So it's accelerating upwards with an acceleration equal to 2.9 meters per second squared. All right, so that's all the information that we have, all right? We don't know the mass of M2, that's what we're trying to figure out. All right, so how many objects do we have? We've got two objects. What are we going to have to do first? We're going to have to first draw free body diagrams or identify all the forces on each one of the objects. So let's take a look at object M1 first. What are the forces on M1? Well, we always have gravity since our object has mass. All right, and so this is going to be mass, so it's just 6 kilograms times 9.8 meters per second squared. The dot back in there. All right, and we've already denoted that it's in the downward direction, so it's going to be negative when we plug it into our equation. So that's one of the forces on M1. What else do we have? Well, the box would be in free fall if it weren't for this cable here. All right, and so there's got to be some force due to tension in our cable, and that's going in the upward direction. Okay, so we have that force in our cable. Are there any other forces? And again, we're really only looking for the y direction forces. There are no x direction forces on our system. So are there any other y direction forces on M1? And the answer would be no. Okay. All right, so let's take a look at M2. M2 over here, again, we have force due to gravity on M2. I'll call it Fg2. And that's going to be equal to M2, right? We don't know the mass, times 9.8 meters per second squared. All right, and again, it's going in the downward direction. We'll include that negative sign when we put that into our equation. Well, it would be in free fall. M2 would be in free fall if it weren't for the cable. So again, we're going to have the force due to tension of the cable. And because our cable is considered a perfect cable, there's no stretch in it or anything, the tension is the same throughout our cable. So Ft is over on the left-hand side is the same Ft that's over on the right-hand side. Okay, so we've identified all of our forces. Now what we need to do is write equations for each one of the blocks. So let's pick M1 first. So the sum of the forces in the y direction for block M1 are going to be Ft, positive because it's going in the upward direction, minus 6 kilograms times 9.8 meters per second squared, all right, because it's going in the downward direction. And what's that going to equal? Well, our acceleration over here is going in the downward direction, okay? So that's going to equal the mass of M1, which is 6 kilograms, times negative 2.9 meters per second squared. All right? It's negative because the acceleration of block M1 is in the downward direction. Even though the force due to tension is in the upward direction, right, the block is going to be accelerating in the downward direction. So that's got to be negative. Okay? So we have numbers here, we have numbers here. We can actually solve for the force due to tension here. So our force due to tension is going to be equal to, the force due to tension minus 6 times 9.8, and that's 58.8 newtons. It's going to equal 6 times negative 2.9, and that turns out to be negative 17.4 newtons. All right. If I add 58.8 newtons to each side, my force due to tension in the rope is going to be 41.4 newtons. So there's my force due to tension. Well, I wasn't really looking for the force due to tension. I'm still looking for M2, but that's okay. That's going to help us out eventually. Let's now look at the forces in the y direction for block M2. I should have labeled this a 1 up here and a 2 down here. All right, so what do we have? Well, again, we have the force due to tension, but we know that that's 41.4 newtons now. So I'm just going to plug that in. 41.4 newtons minus, all right, Fg2. Well, Fg2 is M2 times 9.8 meters per second squared. All right, and the minus sign here is due to the fact that it's going down, so I don't have to stick another minus sign in with the acceleration. The minus sign is already taken care of. All right, what's that going to equal? Well, it's going to equal the mass of M2, all right, M2, times the acceleration of M2. Well, in M2's case, it's accelerating upward, so it's going to be a positive 2.9 meters per second squared. Okay, so what I want to do now is I'd like to collect all my M2 terms together. So I'm going to have 41.4 newtons is going to equal M2, all right, when I bring this over to this side, it becomes positive, times 9.8 meters per second squared plus 2.9 meters per second squared. Okay, and so I've got 41.4 newtons is equal to M2 times 9.8 and 2.9 turn out to 12.7. 12.7 meters per second squared. Okay, and now when I divide, let's give myself a little more room here. I divide 41.4 newtons by 12.7 meters per second squared. Now I get 3.26 kilograms for M2. Okay, and now we've solved for M2. So this is how you do an Atwood machine. All right, it's not that complicated. Again, the keys are in making sure, all right, that we recognize that this equation is our friend up here. It's going to help us to solve all these problems. What did I do? I identified each of the objects in our system, right, M1 and M2. We identified the forces on each one of those objects, then wrote an equation for each object, and then simply solved. Okay. Hope that helps, and have a great day.